Welcome back to class, dear students. In this lesson, we are going to be discussing about control flow in JavaScript, pinpointing on conditional and loops. So what are they as you continue your journey on becoming a pro Web3 front-end developer? So building dApps. Now let's see. When we talk about conditional statement, we've seen some of it previously. Enable your program to decide which block of code to execute based on certain condition. JavaScript offers if-else and switch statements and things like that for this purpose. So, for example, I told you initially that your code runs from top to bottom. So what about if you have a code at the top, but you don't need it to run until a certain condition is met? If that condition is not met, you should skip to the next one. And since JavaScript will run it one after the other top to bottom, then there's no how you can do it. And that's part of the benefit of conditional statements. Because you can now tell JavaScript, cool, before you can execute this code, this condition has to be fulfilled. If not, you need to skip to the next code or to other instruction in the same conditional statement. So that's what, and in case you are hearing any background noise, please, I'm sorry for that. Yeah, now, this is, you can see, we have if-else statement. So this is if the condition is true, then perform this specific first code. But you know, at times it might not be true. When it's not true, what should be done? That's when you have else. So if this condition is true, do this, else do this. Then code to execute if condition is false. So if always evaluate the condition to be true to execute this code. Once the condition is false, it will execute the else statement. So this statement check can execute the corresponding code block based on the result true or false. So for multiple condition, else if can be used. So that means if this condition is true, then do this. Let's say this condition A, but we also want to look for condition B in case A is not true. If B is also true, you can still maybe execute the same code or another code. Then that one will be if condition true, then if else or else if, you understand, else if this condition is also true, then do this, else then you can now use it. So this can continue, but don't make it too excessively long, because all these things can cause bug if you are building a comprehensive dApp. So you don't use them excessively. Yeah. So the second one is switch statement. A statement compared to variables. You know, at the end, we will still use whatever we learn in this lesson in our capstone, where we are trying to build a token minter, full stack token minter dApp. So we are taking it step by step from each lesson, from HTML, CSS, and also through this JavaScript as well. So let's look at this. Switch is also like if else, compare a variable against multiple cases and execute the matching block of code. So like case, value 1, code for value 1, break, case, value 2, code. So this break, because this switch statement is like, it will continue going, like, so you need to be breaking it off, that okay, maybe if this code has been executed, you can just break. Then if this case 2 is executed, you can, if not, it's like things will continue to be executed. And this one is like, if any of these cases isn't working, what should be the default? So you see, it's almost like similar to if-else statement, but I think this is more usable in a kind of when the situation is more like complex. Instead of else if, you can use switch case syntax instead. So we have the loop as well. Loop are used to repeat actions. You can see this now, that for initialization, the condition, and the increment, code to be executed on each iteration. So, as a developer, we always want to look for smarter, faster way to get things done. So that's when you talk about JavaScript loop. It's different from if this, do this. This one is like you want to repeat something. Let's say you want to run a code block 100 times. You don't want to write a code 100 times that one, do this, then come back again, do number 2, do number 3. You can just write the single execution code, since it's the same thing to be done, and tell it some adjustment it needs to be doing. Maybe for each, let's say you are doing 1 plus 1 equals to 2, 1 plus 2 equals to 3, 1 plus 3 equals to 4. So that is predictable because you can always have an increment of 1 for the condition, like, okay, I want to do it up to 100. That's like maybe 99. So once it's 99 and it add 1, it becomes 100. Then I want the code to stop. So instead of writing a long 100 code for each one, like I've said, 1 plus 1, then I get to 1 plus 50, 1 plus 52, 1 plus 65. You don't want to have all those things. That is so cumbersome. You can just have this little code that keep checking that, okay, I'm initializing this code, that this code now is at 1 to 0, which is like this I now is in 0. Then the condition is as long as this I is less than 0. We initialize now I equals to 0. So this thing will continue to execute as long as I is less than 100. Once it gets 100, it will crash, or it will stop. Now, you will increment it by 1, which means each time this code run again and again, you will add by 1. So it's like 1 plus 1 equals to 2, then comes back again. The condition here is met because it's still less than 100. You understand? So then that's how you will do it. We also have something like this. Let's see if, let me try and pull this up. I was just trying to check those code we run before, but like I said, we'll still do the practical, so you don't feel it's just theory alone. And that's why you have the sample codes as well, to give you a more realistic example of the code. So let's keep on. We have while condition. Why you can use this loop to keep on. You can also use while condition. It's the same thing, but the way you present it, the way you arrange your requirements, your condition, and your increment, or whatever you want it to execute. So you say why this condition is true, just like that if statement. Continue to execute this code. Maybe as long as I is less than 100, you continue to add 1, which will be part of this code. But once it's equal to or greater than 100, then automatically you cut out of the loop. So if not, your loop will be infinite and crash your system or whatever project you are running on, crash your users' memory, system memory or PC memory, because it will continue running. That's why there will always be a condition that makes it to be finite. Your condition should not be infinite. So then do while loop as well, similar to while loop, but ensure the code block is executed at least once. Because when you see, the problem here is that why this condition, so which means if this condition is never true, this code may never run at all. But when you say do this code, then why? So pending when you are confirming this condition is true or not, make sure you execute this first code. But then when you finish this code, confirm this condition. If this condition is now false, then don't go back to execute to continue to execute this code. But at least you may need to execute it one time. But in case this condition is now met, then you can repeat it again. You understand? So instead of here that it check the condition, if the condition is not met, this code is not even started at all before. But if it's met, it will do the code, then come back again, come back until this condition is false. But in this case, it will execute the code first, then check, is this condition still true? If it's true, then it can come back again and things like that. So then let's now look at example code, which usually will follow to expand our token minter that we are gradually building out. So usually I try to add the existing code in case you mix things, which is good. Try to break code, try it, and it's even AI age. You always have this AI to help you sort things out. So in case you mix things, these are existing code we have. Then after we make the changes, we enhance it. This is what we have now. And you will see that we try to add some condition to it, which, remember from the previous code, is this. I said we have a to-do. Let's minimize this or hide this. So we have a to-do here, which is, in the next lesson, we will add validation to check the correctness. So you can watch the previous lesson. I won't go back again. We add like an issue there which we can launch, because anybody can meet as much as possible. They don't even need to put a wallet. There's no verification to check, is it a wallet? You get things like that. So all those things are what you want to check. We can even check, is it like an Ethereum wallet? Is it a Solana wallet? Is it maybe a Avalanche wallet? You can program all those things to ensure other people cannot just put in or waste your time on the project or on the dApp and things like that. So you can do all those checks, and we'll do some here. Let's try and copy this and see the check that has been done. So to always ensure you are on the same page, I do always recommend that you copy everything again, since I've put it there for you. Then replace this. Let's see what we've got before then. Yeah, like I said, watch the previous lesson. I won't go back to that. So you should know the error we had there earlier, which we want to fix. So over here now, we remove this and fix this. Then we save. Now from henceforth now, things like non-available or zero minting, let's try it. You see, minting token, yeah. I think we have not, have we refreshed this? Let's see. Please enter a value. Now see, we now started having check. So before it was not available or things like that, and we can even mint like zero before. But now it's saying enter a valid wallet address and a positive number of token to mint. You are beginning to see that the conditional statements are kicking in, because we need to check if this wallet is there. If it's there, we can even check, like I said, is it Ethereum wallet? It has this number of string and things like that. Is it Solana wallet? You understand, things like that. Yeah, or it is either it is Ethereum or things like that. That's where we can use the operand or and, which we have learned as well previously. So those are the things you will say, and you will say validating wallet address. If wallet address, when you look at this, it's like opposite. This one is like same as this and is not. So this one is not. When you say this is equal to and you see this sign, that means not equal to. You know the basic mathematics then. So it will check for all this and token amount greater than 0. You understand? If wallet not equivalent or not equal to empty, and also check it that not is not available, remember the previous error, token amount must not be not available, and token amount must also be greater than 0. So that's why when we try to mint with 0, it's not working. Even if we try to put a wallet here, it will not still work. If we put 1 and we don't put wallet, it will tell us, please enter a valid wallet address and name. So we can decide to even split it, so we know when the issue is wallet. But that's just the basic. At least now it works better to checkmate the user compared to before. They can just mint even not available. They can mint 0, they can mint billions of tokens before, but no more now. So core function to update minted token and get results. You will see that first we'll begin to set this. We had that before, but now we now set mint token limit. Set a limit for total token that can be minted. You remember I told you earlier. So now we are now using const, because if we use let, a bad actor can come into a dApp, you understand, and then maybe we are doing an airdrop for individual. Each time they are minting, they shouldn't be able to mint into each wallet more than 10,000, or you understand? Yeah, let's assume they are minting the airdrop directly. So if we use let, they can find a loophole and manipulate this, and then that person want to mint and then mint 100,000 token. You get the point? Yeah. So, but since we have used const, we have limited. There is no way they can be able to mint, even if they mint multiple times. Once it hit this 10,000, they are cut off automatically due to that check. So that's all those things that are so important that we put here. And you see all these cons, mint button, all these ones are what we have learned. I think we also learned some more about them, about manipulating the DOM. The DOM is, you will learn about them, just keep that in mind. This allows us to be able to manipulate the memory currently like we are using to render this page. So that's able to allow us to check this person that is minting now, what has he minted and things like that. Though when you are doing an actual one, it will be more robust. That is not just about the DOM, because the person can refresh and then start minting again and start over. Once they refresh, now this thing will restart. You understand? But when it is a actual real life dApp, once you get to that level that want to actually use it, then we'll make this check more robust. So this check, if you are doing it like minting now, you might have had list of wallets that can mint, and the check will be based on each wallet. Each wallet cannot mint more than 10,000. So if they like, let them refresh the website 1,000 times. It will keep telling them you have minted 9,000 previously. So you mint 1,000 more, you are off the table. Come over how many times, use different browser, use different IP, it doesn't matter. Because that thing is checking the wallet. As long as, imagine this wallet is placed here, that as long as it is this wallet and it doesn't have 10,000 minted earlier, then you should mint. Once it has it minted, even if it has transferred it, you are not checking the balance. You are only checking to confirm that it has minted it before. So straight, it can't work again. So I'm just trying to expand on how these things can work for you. And you see, let mint result equals to update. We call this function which gets updated with token mint. And this is the function A. The function is, remember I told you in JavaScript, when you write a function, it does not, it's just there. You need to call it somewhere to activate it, like a button is there. You need to click it or tap it or do anything or swipe on it to activate whatever is behind it. So the same thing happens with this. So we're activating it and set successful minted first, then let, and you can see now for it, let I equals to 0, which is what? The for loop. Now, then I greater than amount, then plus. So whatever we are adding the I plus, it will add. So if token minted is greater than minting limit, you see, it's less than, sorry, when it's like this. So it's like this that is greater than, this greater than, and this less than. So when it's less than mint limit, then total minted should plus whatever you have here. Then successful minted equals to true. Then at the same time, it will add it to this total minted. You see all those things. Then at the same time, it will alert minting limit reached. Once this is false, it will stop this iteration. You see, as long as it's less than, the amount is still less than this mint limit. So let's quickly test that before we go from the lesson. So let's see this now. We have this, we have seen it that you can't mint 0. Then you also need a wallet. Let's just put, we didn't check wallet, so it gives us the opportunity to type anything in the wallet, but the wallet can be empty. So let's put 1 and let's put nothing. It will not mint. Let's put something here and put 0 or nothing. It will not mint. Put 0, it will not mint. Because all these checks, you can see why this is so important. It helps you secure. That's why if there's any loop in this thing that you say is being hacked on, things like that. So don't joke, they can manipulate your smart contract from the front end. So many times people don't like hack a site, a smart contract just directly through the smart contract. Usually at times it happens that they look for loophole in the front end of the dApp and then use it to take advantage of the smart contract behind it. So that's why you can't take it with levity as well. So now let's try to mint 1000 token. You see, minting 1000 token to W, which is from this mint. No, sorry, this is from this minting. And remember what I told you earlier when we are doing concatenation. This is another form of concatenation. The previous one is the old one when you use plus. You understand? So here now you are using the, I was telling you there's another one which is, I think we call it like literal. Like a literal means, which means you use this symbol. You can see it from here. And you can use the what do you call it, the JavaScript variable or whatever directly using this wrap, the $sign, and then you wrap it inside there. So you can use the JavaScript in between instead of using the plus and then the something. So if I use this now, and use the old one, it will still serve the same purpose. So but let's just, you can use it, maybe you just try it and test it yourself, so I don't spend additional time on that. So that's where you are saying it is able to pick the token. Remember when I told you about the variable being a container, like that water bottle holding it. So then you begin to see, so different users are coming now. You won't manually need to go and be changing. Imagine it's just a minting 10 token, then another person mint 10,000. It won't give correct something. So, but with this now, it dynamically updates based on whatever the user mints. Then also the wallet, it put the wallet here. You can see it now. So now, if I decide to mint 3,000, you will see it will change. You see 3,000 token minted. But you see that this is also getting updated because update minting token is updating it immediately we mint, and this has the ID. Remember the ID token total minted, which is being updated from here. You understand? So we are able to update this from there. Let's go back. So that's how you get this done. Let's keep going. Let's try 2000. It's keep going, nothing happened here. Let's try 5,000. Then bam, minting limit reached. No more token can be minted. But once I refresh, minting 5,000 token to this, it has given me the error. These are things you will have to check, but you will see what will happen now. You see, it still allow me to mint the remaining gap that remain out of the 5,000 I wanted to mint. I think I was able to mint maybe 3,000 or 4,000 or so. So now it's 10,000. Look at what will happen next. You see, and then it doesn't give me option again. So all these are the loophole you may try to ensure. If they put amount more than, it should not even mint anything at all. It should cancel. So all this will be done with the help of your conditional statement, your control flow. That's why they call it control flow. Your ability to control the flow of your program with all these conditionals and loop. So always try to use them only when it's needed. And when it's needed, don't ignore using them to keep your dApp secure. So that's how we are able to, come about this. Let's see, mint successfully. So that's it for this lesson. And remember, the resources are there for you to consult. Some of them also help me in creating the content as well. So you can consult them to learn more if you would like to learn more. But always remember, you also have the AI to support and help. Have any question, use the comment for specific something. Don't ask question about JavaScript variable under conditional. You won't get support, you won't get response, it might even be deleted. And please take time to read other student questions. You will learn a lot from it. And also it prevents you repeating the same question. You understand? So if you ask question and it's not answered, it might be because you have not done your homework. You may need to go back, read out some other student question, you learn even more like that. So that's how we end this lesson, and then the next one will continue in the JavaScript for Web3 front-end development. I remain Solomon Foske of dProgramming University. Keep the programming spirit high and alive, and please always do good to humanity and nature with your knowledge and your programming skill, and not evil, to make the world and the universe a better place for us all. That's it. See you in the next lesson. Bye.